Welcome. Today's section is over 6-1 angle measure. This will be part 2. Here we'll talk about four formulas. Length of an arc, where we will use S equals R theta. Area of a sector, where its area equals 1/2 times R squared times theta. Angle or angular speed, where its omega equals theta over t. And then linear speed, which has two formulas, where you have V equals S over t, or V equals R times omega. Now, for our arc and our sector values, they cannot be like in degrees, they must be in radians for it to work. Okay? I think it's because of how the unit circle is set up. And since length is in radians anyway, having it in degrees will give you something abnormal and it won't really quite make sense. And then for angular speed, same thing. You will want everything in radians as well. Now, just to give you a background, everything that we measure is kind of actually in radians. I know that like we use the words inches and feet and centimeters and miles to describe things, but really, if we are converting things, the base measurement for all our units of measure is actually in radians. It's just that our other units of measure trump the word radian, so we really never talk about it until we get to a class like trigonometry. So here, that's what we'll be talking about. So for the first example, I want to find the length of an arc when the radius is 10 centimeters and the angle, or the central angle, is 15 degrees. So here, just like I said, since it's at 15 degrees, I need to use what I learned in part 1, and I need to convert 15 degrees into rads. So I need to use pi over 180. So my degrees cancel out. I multiply across, give me 15 pi over 180. That will give me pi over 12. And so that'll be the theta that I use for my equation. So to reiterate, S equals R times theta. So S stands for arc length. R, remember, stands for your radius, and theta is the angle measurement. So if I plug in what I know, so 10 centimeters is my radius, and then pi over 12 is my radian measurement. So then here I can do a little simplification. So that gives me 5 pi over 6, and that would be in centimeters. Okay, just like I said, centimeters trumps radians. Even though this is radians, this one's centimeters. So centimeters trumps rads. So that's what my label would be. Next one, I want to find the area of the sector when the central angle of 50 degrees and the radius is 3 meters. So here, same thing, I need to change 50 degrees into radians. So pi over 180 needs to be multiplied to 50. The degrees cancel each other out. I multiply across, gets me 50 pi over 180. So here I can actually reduce both of them by 10. That gives me 5 pi over 18. And so my formula will be area equals 1/2 times R squared times theta. So 1/2, my radius, I said, was 3 meters. So I put in 3 squared times 5 pi over 18. So here, squaring my 9, so 1/2 times 9 times 5 pi over 18 and then multiply across. That gives me 45 pi over 36. I believe each one of these has a 9 in common, so I can reduce by 9. That gives me 5, and that gives me 4, I believe. So actually here I get 5 pi over 4, and then this one would be in meters squared, would be my unit of measurement. So we're talking about area. Next example, I want to find the angular speed and linear speed for the following case. Here it says a boy is riding a merry-go-round at 12 revolutions per 10 seconds. The radius of the merry-go-round is 4 feet. So here first we need to find angular speed. So I'm already given something that's kind of like angular speed, which is the 12 revolutions per 10 seconds. Okay, 12 revolutions needs to be first converted into radian measurement. So I need to take this, and if you think about our 360 is the same thing as 2 pi discussion, well, that's also the same thing as 1 revolution around the circle. Okay, so here, if I want to convert into radians, I would use the 2 pi and 1 rev conversion. So 2 pi divided by 1 revolution. So the revs cancel out, and multiplying across gives me 24 pi rads. And then here, to get my angular speed, you want to take your angular measurement, so your angle, which is the 24 pi rads, and divide it by the time. So here, dividing by 10 gives me, we'll divide by 2, so that gives me 12, and that gives me 5. So it'll be 12 pi radians per 5 seconds. Okay, so that'll be my unit of measurement. Okay, so then there's the angular speed. So I'm done with the first part of this example. Then I need to find linear speed. Now, like I said before, you can do it one of two ways. You can use your arc length divided by time, which you have to go back and use the arc length formula to do. Or you can just take radius times your omega, which is what your angular speed is represented by. So that one, since we already have angular speed, is a lot easier to use. So my radius was 4 feet. So taking that times 12 pi over 5 for my angular speed, that gives me 48 pi over 5. And that's going to be feet per second. Okay. Now for both of these, it probably doesn't make quite too much sense if everything's in pi when you're actually talking about like a distance value. Now for radians, it's okay to leave it as pi because that's what radians is usually in. But for linear speed, it would probably make more sense for us to actually convert this to a decimal form to actually get an approximate answer. So let's do that right now since we have the ability. So 48 times pi gives me 150.796 approximately. And then I divide that by the 5 seconds. So that gives me an equivalent of 30.2 feet per second. Okay, so that would be another possible way of writing your answer. I believe this one was more exact, so if you leave it like that, that would be also correct. And that concludes today's lesson.